Hi everyone. So in this class, let's see the differences between stateful and stateless applications. So how it works internally, because I want to solve few questions on stateful sets. So I just want to clear it up, whatever the concepts of these stateful sets. So before you understand what is the stateful sets, you need to basically understand the differences first, like how it is happening inside. Okay, so for that, let's first come into normal service, which is using cluster IP. So if you have created any time the stateful sets, you will be creating the headless services. So what is the difference between normal service and headless service, and what are stateful apps and stateless apps? So all those things we'll see in this lecture. Okay. Now let me come to the stateless apps. So the stateless apps are any virtual applications, etc. So let's start with this. Now you have a standard cluster IP service here, right? You can see that there is a standard cluster IP service, and we use this as for the stateless applications. Okay, and think of this stateless applications like a standard web backend or a front end, where all the pods are identical clones. Okay, so whatever the pods are there here, all these are like identical clones. Okay, and so that it doesn't matter for us like to which application it will send the request to. So these are all identical clones. Okay, that is one thing. And the DNS of here will return the IP address. Okay, well, let's say it returns only one single IP address. This is known as the cluster IP address. Okay, this is the cluster's IP address. Now when a traffic hits the cluster IP, so how does it come from? Any pod or any client will have to access the application pods. Now then what happens, the DNS come into picture, and it will translate this particular my app service, default service local, and to a particular IP address, and this IP address is of the service cluster IP's IP address, virtual IP address. And this because this cluster IP will now send a traffic to the Kubernetes proxy. So here comes into the picture of proxy, which load balances the traffic between the identical pods. So whenever one of these pods are down, it doesn't matter to us which application pod is down or not. Okay, it will just load balance. For suppose this got deleted, then proxy will basically balances the traffic between these two pods, and it will after this is up, then again it will take the traffic to that pod as well. So that is the work of proxy here. Slowly we are getting into the architecture. I know it's overwhelming. So if you see here how different it is from headless service, we will see now. Basically the DNS is not having the IP address of all the pods running inside our cluster on that node. It is not having that particular IP addresses. It is just having a single IP address, and that is of the cluster IP. So this cluster IP is what is managing the pods inside our node. Now these pods are also not managed directly. Instead, the cluster IP sends this to a proxy, and this proxy is managing the load between the pod endpoints, and so we don't need the IP addresses of this thing. It is not needed, and even one or two pods are down, it is fine for us, right? So that is how it is working. And basically this happens in stateless applications. Okay, now let's come to a high level understanding of stateful applications. So in stateful applications we are using headless services. Okay, so headless service, we use this for stateful applications like databases, MySQL, or some message brokers like Kafka. So in database cluster, pods aren't identical. Okay, they are like disposable clones. They are not disposable clones, right? So they are just important as other. So you usually have a primary node, and that let's say this is handling the write operations. Similarly, this handles the read operations. This handles both the read and write. So like that, every replica is having its purpose, and they are not identical here. So let's say these two are reading and one is writing. So because of this, the pods need to know who exactly they are talking to, right? So they need some identities, stable identities, right? So whenever a request comes, that has to identify, I need to talk to a specific pod 1 to write into that database. Okay, or I need not access pod 1, and I want to access other 2 just to read. So it has to identify to which particular pod it has to talk to. So that's why there is no need of queue proxy, because there is no need of load balancing here. So there is direct access from pod to those particular pods. So there is no queue proxy here, and because of this we need stable names, right? The predictable names like this, MySQL 0, 1, 2, that way. And more importantly, the headless service gives each of these specific pods its own dedicated stable DNS record. If you see in this normal cluster IP service, there is a DNS IP, but that belongs to a cluster IP which manages the pod's IP addresses, and we don't need this IP address. We need a cluster IP address which is stable, and that is given by the DNS. But here what happens is, see, pods are unpredictable. They will go down and then they will come up due to different reasons. So we need specific DNS names for this, like attached to that particular pod, and whenever it goes down or recreated, again it has to get the same name, because those names are used in the DNS and are referred by the pod. So that's why you need, if you see this is like this, right? So it will be like MySQL 0 and MySQL Headless Service dot default, like that. Okay, it attaches like that. So to summarize, why behind this, why don't we just give normal stateless pods their own DNS names? Because we want them abstracted, right? If we exposed their direct IP addresses, clients might connect to, or our any service will connect to a specific pod, and if that pod crashes, as I told before, the client connection breaks. Hiding them behind a cluster IP makes scaling and replacement invisible to the user. So that is in the stateless applications. Okay, that's why we don't expose the direct IPs, because it is unpredictable. But for the stateful apps, the abstraction breaks here, so that's why they are able to see directly the IPs and DNS names. The MySQL replica must connect to exactly MySQL primary node to sync its data. Like that, it needs a specific pod to which it has to create to. That's why the need of the headless service is there here, because headless means what? Headless means what? You know what is head here? Head is the IP address and IP address of the cluster. And if you remove this IP address of the cluster, it becomes headless. I'm sorry, I'm writing here. So basically headless means IP address is removed, of which? Of cluster. So cluster IP is not there. That's why this headless IP address, because it is headless IP address, the DNS will be referring to the IPs of the pods of our stateful applications. So like that it works. And in coming section we will see the below points, like specifically we will see the what is stateful, how to create the stateful sets, and how they are binding to the particular PVC. For suppose in the stateful set YAML, we can specify to create a PVC, and this PVC is also binded to particular pod, so that if the pod goes down or crashes, again it gets recreated without manual recreation. It gets up, and it will take the same stable DNS name even though the IP address is changed. So and one more thing is this particular pod will be attached to the same PVC as before. The PVCs won't change, like this won't get attached to this after it recreates. So that is what we are doing in stateful apps, and we will see the demonstration of this in the next class. So thank you so much. Bye bye.